Element number 1 on the periodic table is hydrogen. The atomic symbol for hydrogen is H. Hydrogen is a very light, odorless, and colorless gas that is extremely flammable. Hydrogen is the simplest element and the most abundant in the universe. Hydrogen gets its name from the Greek words hydor and genomai, which means to bring forth water, because when hydrogen is burned, it produces water. Hydrogen is classified as a non-metal. It lies in the periodic table's first row, period 1. Each hydrogen atom consists of one electron that surrounds a compact nucleus, which contains almost all of the atom's mass. In the most common form of hydrogen, its nucleus has only one positively charged proton. Unlike all other elements, hydrogen has no uncharged neutrons in its nucleus. One negatively charged electron balances hydrogen's one proton. Hydrogen's electron is found in the single orbital shell that surrounds the nucleus, the sphere-shaped 1s shell. This single valence electron determines hydrogen's unique chemical behavior and makes hydrogen highly reactive. In this experiment, a partly filled plastic bottle contains hydrogen above water. When the water is emptied from the bottle, air, which contains 20% oxygen, rushes in to take its place. When a lit taper is placed near the bottle's opening, the hydrogen and oxygen ignite to project the plastic bottle through the air like a rocket. The products of this explosion are water vapor and a lot of heat. Hydrogen is a very important commercial element. It combines with numerous other elements to form chemical compounds that we use every day, such as water, table sugar, ammonia, and hydrogen peroxide. Liquid hydrogen is often combined with liquid oxygen to make rocket fuel. America's first mass-produced automobiles rolled off assembly lines in the early 1900s. Today's cars are much more efficient, more powerful, and more advanced. But most still use the same fuel as the cars of 100 years ago: gasoline. When car engines burn gasoline, they release carbon monoxide, nitrogen oxides, and other harmful chemicals into the air. These gases cause smog and acid rain, and many scientists believe they may also contribute to global warming. Gasoline is made from non-renewable fossil fuels such as petroleum, coal, and natural gas that take millions of years to form deep inside the earth. Once the current supplies of these fuels are used up, they are gone for good. Scientists the world over are working on finding alternative fuel sources for the cars of the future. Modern hybrid technology, which uses a combination of gasoline and electricity to power a car, is becoming popular. Hybrid cars are much more efficient than those using conventional engines, but they still rely on the same limited resources as gasoline-powered cars. So some engineers are working on ways to make cars run not on gasoline or hybrid electricity, but on the limitless resource of hydrogen. Hydrogen is the most abundant element in the universe. It makes up more than 90% of all the matter in existence. It is colorless, odorless, tasteless, non-toxic, and highly combustible. Hydrogen has been used to power rocket engines and make devastating bombs. But it is not the combustible nature of hydrogen that makes it a good possible fuel for the future. Instead, it is a basic chemical reaction that scientists have understood for over 150 years. The elements hydrogen and oxygen have a natural attraction to each other. Together, they form water, and when they combine, their chemical reaction releases electricity. This is the principle behind the hydrogen fuel cell. Originally developed for the Gemini space program in the 1960s, fuel cells combine hydrogen, the green atoms, and oxygen, the blue, to produce electricity. Inside the fuel cell, a platinum catalyst splits atoms of hydrogen into positively charged protons and negatively charged electrons. The protons pass through a membrane to bond with oxygen on the other side. The electrons are blocked by the membrane and must flow around it through an electric circuit to recombine with the hydrogen and oxygen and form water. When an electric motor is plugged into this circuit, the electron current is enough to power a car. The only waste product of the process is water. Hydrogen fuel cells have no mechanical parts, such as a transmission, do not operate at high temperatures, and do not need lubricating oils. So maintaining fuel cells should be easier and cheaper than traditional engines. Practical fuel cell cars are still a long way off. Today, it is about 20% more expensive to make hydrogen than a comparable amount of gasoline. And scientists must develop better ways to store hydrogen. Fuel cells are much larger and more expensive than traditional gasoline engines. And current gas stations do not deliver hydrogen to drivers. So most hydrogen-powered cars on the road today are prototypes or test vehicles. But improvements in the technology could one day solve these problems and provide a reliable, efficient, and clean-burning fuel source for centuries to come.